If you take a look at my FRQ suggestions, that's one of the first ones on there. So read through that and just jot down some notes before you start doing any of these. So here's what I'm going to do. I'm going to make up, this is my first attempt at making up a design investigation problem. So I don't know if this is going to be any good or not, but follow along with me, and here's what I want you to do. I want you to go through this with me together, and we'll talk through how to do it. And then afterwards, I'll give you a chance to do one by yourself. Is that easy enough? So look at this one and follow along with me. We'll start with this. Design investigation. It says and. A business-friendly administration is elected to office. They direct the EPA to reduce its atrazine, an endocrine disruptor. We know what an endocrine disruptor is?
Yep.
What does atrazine do?
That's what the sexes of animals.
Most specifically,
Frogs.
the frogs. Okay, thank you. All right, endocrine disruptor. And they are, reducing the level advisory for maximum levels allowed in rivers, lakes, and streams. Okay? They're reducing that because it's more business friendly. Yeah, they can just dump what they want to wherever they want to. So, you as an environmental scientist have to do the following. If you take a look up here. All right, the current level of atrazine allowed is about 10 ppb, which is parts per billion. That means 10 atoms out of a billion are going to be atrazine. That's how few that's allowed in there. Does that make sense?
Yeah.
And now, continuing. Design investigation to analyze levels of atrazine and the effects on frog populations. So my question for you is this right now. What kind of an investigation would you be doing? What would be the basics of your investigation? Yeah, establishing things, but I mean like just the general scope. Now in your mind you're thinking about, okay, what kind of investigation am I going to do? I'm going to if I'm trying to see the effect of atrazine on frogs, the general idea is I'm going to take some frogs and then expose them to atrazine. That's the basics of my investigation. Is that fair? Okay, and then see the effects. Or more specifically, I should say, exposing the atrazine to the developing frogs. Well, let's start with this. The first thing they're usually going to ask for is what? What is a hypothesis? What you know or think, I mean, kind of.
It's an educated guess.
Educated guess, yeah, but a guess about what? The outcome, yeah. The answer to the question. If you start off with a question, right, the hypothesis is the answer to that question, okay? It's just your expectations for the problem. And these are three things that I talked about, and I suggested that you read over, right? And be honest with yourself, thinking for a second, did you bother reading over these vocabulary terms that I gave you earlier? Because they matter.
Yeah.
So we'll start with this. A directional hypothesis. Give me a directional hypothesis for this atrazine and frog situation.
When frogs are exposed to atrazine.
All right, let me hear from Stephen, because I heard him on here. It's harder for people online to speak. Go ahead, Stephen.
Sorry. When these frogs are exposed to atrazine, something will go up or down. It has to go in one of those specific directions that you specify.
Yeah, All right, but you didn't really give me an effect. You said, all right, so something goes up.
Like, it will have a negative effects on the frog's reproductive systems or something like that.
A negative effect. So you have to give some direction here, right? So what about the atrazine? If atrazine...
It's exposed to frogs, it will have a negative effect on them.
A negative effect on them, on their reproductive health. I guess, yeah. So it's saying, yeah, if you have more atrazine, right, you're going to have, you could even phrase it this way, more reproductive problems.
Yeah.
Yes? Right? Or more health issues, you could say it that way, right? A negative effect, or you could say a negative effect on the reproduction. That's fine. A non-directional hypothesis.
Is it like, if it just doesn't, it will have an effect?
Yeah. So, yeah. Is there an effect of atrazine on frog reproductive systems? Does that make sense?
Yeah.
And then lastly, the null one,
It will have an effect.
atrazine will not have an effect. Okay? All right, so we come over here. Next up, variables. I want you to look at these terms here because they partner up, they pair up.
Mm-hmm.
So I'm curious as to who knows which ones partner up here.
Dependent is responding, independent is manipulating.
Yeah.
Your dependent variable is the responding one, your independent is the manipulated. Now, I personally prefer this language because this implies that you are causing the effects, right? If you're the one planning this investigation, this is how you should view it, okay? Just studies of the natural world, you could certainly use these terms. But I like this better because it explains what you're doing more, all right? Why do we use those? I mean, because it makes sense. Independent operates on its own, right? And the dependent responds to it. But there's not necessarily a human influence on it.
Yeah.
When I say manipulate comes from hand. Like humans are physically doing this. Okay? So, if we're looking at this, and you're going to be designing this experiment here, okay, with atrazine and frog gender, or frog reproduction, what's going to be your manipulated or independent variable?
The amount of atrazine.
Yeah, it's got to be the atrazine, okay? And if I can, that's because you're going to be affecting that. You can affect that and by changing it, right?
Yeah.
Now, what will respond to that? Right, the frogs are going to respond to that, right? Okay, so manipulated, responding, independent, dependent. This one is dependent upon this one, okay? All right, so investigation itself. How can you be sure it's only the atrazine? When you're designing your experiment, you have to make sure that atrazine is the only possible thing that could be causing any issues. So my question to you is, as a designer of an investigation, right, how can you make sure it's only atrazine, your manipulated variable, that is having an effect? What do you do as a scientist to make sure?
Just make sure that like each testing, like, you know, like, or I guess you should have the frogs because I'm assuming that you're creating the environment and not putting it in.
Yeah, you're creating the environment, yeah.
Then just have it mimic as closely as possible their actual environment. Where
Maybe mimic the environment. That's getting close to it, yeah.
Having a control group and making sure your experiment is repeatable with repeated experiments.
Having a control group is big, okay? What is a control group? What is a control exactly?
It is the group that does not receive the treatment.
It's a group of frogs that do not receive the treatment, okay? If I want to prove that my treatment or my manipulated variable, right, whatever I'm treating, whatever I'm doing to it, okay? If I want to prove that that has an effect, I have to show that without it, there would be no effect. And that's your control, right? Okay, good. That makes a big difference there, right? But again, just one more time here, control is important, okay? Establishing a baseline, but that's not going to make sure that it's just the atrazine. There's so many things that could be affecting these frogs. And you're close to it. There's another word that I'm looking for here. When you have a whole bunch of experiments, you're going to need like 3 different sets. What's that? Repetition comes in this one down here. How can you be sure that luck doesn't play a role? If I don't want luck to play a role, I don't just do it one time, I got to do it multiple times. So this is the repetition side here. Okay? What is this here? Constant. Not just constant, constants. Right? When you do an equation, what's x? X is not a constant. X is a variable. That's why we call it a variable. What is x? 1. How do I know that? Everything else on here is constant. It makes it easy to determine the answer. What if I do this? Now what's x?
Some Minecraft engineering.
You don't know. You will never solve this problem. Why not?
Because you don't know what
You don't know what y is. I cannot tell what x is not knowing what y is. The more variables I have, the more uncertainty there is in my problem, right? If I conduct my atrazine trial in in a bathtub, and then I do another trial in the wilderness, there could be so many differences there that are affecting their gender. You have to have constants that you keep the same for each group. And you have to make sure that you write that you are keeping everything constant. Does that make sense? Yes? Okay, so again, one more time though, there with the luck thing. How can we be sure that luck doesn't affect your results? Do multiple trials. And that's something that I shouldn't have to be asking for. That's something you guys have known since elementary school. So a couple things here. Constants must be listed, right? Try to list as many of them as you can. You don't have to get all of them, but get as many of them as you can. The control must be determined. This is a big one. You've got to make sure you label the control and tell them what it is. Show them that you understand how to do this. Next, repetition must occur. So you got to say that you're going to repeat this trial multiple times. What's the general number? 3 times, okay? And don't just do it to like 1 frog. Do like a dozen, 100 frogs. Does that kind of make sense? Use as many numbers as you want. Show that you understand what's going on. Manipulated variable must be applied in gradients. Small, medium, and large. What was my example in my design and investigation video, for those who watched that? What was my experiment in there that I was using?
Water glasses.
Water glasses, right? And how much water is needed to affect plant growth.
Yeah.
I did one with a little bit, one with a medium amount, and one with a lot. Okay, and then of course I also had my control, which would be with no water, because that was my treatment I was applying. Does that make sense?
Yeah.
Yes? Okay, so small, medium, and large amounts. Okay, now, also in your experiment, you must think about what's going to happen afterwards. How are you going to know if your experiment had any effect? Well, you have to record what? And tell them what you're going to record. If I got a whole bunch of frogs, right, that are changing gender, what should I probably be recording? The gender when?
Before and after.
Before and after, right? Or just the reproductive parts, right?
Yeah.
To collect some data, some observations on their genitalia before and after the experiment. Lastly, you should also be prepared to predict the results of your investigation. So tell them what you expect to find. Are we cool with all this so far? Okay. So, here's your chance now.
Mr. Ellis?
Oh yeah, go ahead.
Is it still possible to get the prediction of the results wrong if it does not meet like environmental?
The prediction is just your best guess. But at the same time, if we're talking about atrazine, they're going to expect that you know atrazine would cause what?
Right. Okay.
Yeah, so they expect you just to know that. You don't have to be right, you're just making a prediction. Okay, if I can here, here's your investigations. Please listen carefully. Deforestation is occurring downstream of a freshwater aquatic preserve. What's a preserve? A what? A place they crawl out? What does it mean to preserve something?
Like an isolated amount of fresh
An isolated area, a protected area, right? It's a preserve. A nature preserve is preserved. It's conserved. It's saved, yes?
Yeah.
Okay. Now, conservationists are concerned about the effects of erosion and increased turbidity in the ecosystem. Why are they concerned about erosion all of a sudden?
Because when you cut down trees, the roots don't hold
The soil is much anymore, right? And it's going to increase the turbidity. What is turbidity?
the amount of the
soil and things in the water.
Not just the nutrients, it's just stuff. Dissolved solids is the technical term. It could be sediment, it could be nutrients, right? It doesn't matter, it's just stuff in the water. Okay, so if I can, design an investigation that could help provide information on the effects of increased turbidity. Okay, so again, they're concerned about it, so you have to conduct a study. So the question is this: increased turbidity. What should we investigate if there is increased turbidity?
Water
I mean, yeah, you're investigating the water downstream. What are you investigating about that water?
the amount of turbidity and then the effect that has.
The effect that it has. So you need to know what the effect it has. So what effect would turbidity have on the freshwater ecosystem there?
It can mess with fish and plants that need sunlight and stuff, as well as just kill fish in general because of things like.
So that's typical of a student's answer in here. You give me a good bunch of information, but you give me way too much. Pick one. Okay? So if you're picking one thing to investigate, turbidity's effect on what? You could do animals, but I mean, honestly, turbidity isn't as that big a deal for animals. It should be clearly more of a deal for plants, because they need what? Sunlight. Turbidity will interrupt that, right? So go with the most basic and easy and obvious here, okay? All right, so always two variables. So we have the level of turbidity affecting the amount of? What'd you say? Plants, you can do plants. I would also say light, something that's easy to measure, right? Something I can measure easily. So light, because the plants are dependent on, but you can do plants as well. That's a good guess. Okay, so what do we need for an investigation? Well, we need the water from there, right? And we also need something to measure what? The sunlight, okay? The amount of sunlight coming through there. Okay, what do I have on here next? Is there anything else? Okay, good. All right, now it's your turn to design an investigation. Okay, now that I've gone over all this and talked about it, I feel like you don't need more than maybe 10 or 15 minutes to design an investigation. Have I already gone through what's required in an investigation?
Yes.
I sure have. You're going to have to use your memory because you're going to have to know this. So hopefully if you've been jotting down notes, I guess that's good or whatever, but it's better off that you know. If you have questions for me, ask. But as of right now, if you want to talk with someone and work on it, feel free. Otherwise, give me some responses here in the next 10 or 15 minutes. Go.
Where are you supposed to write this down?
On a computer, on a sheet of paper, it doesn't matter. Just come up with some kind of investigation somewhere. Yes?
The effects of increased turbidity on what?
Good question. That's up to you.
Okay.
I just talked about it a little bit, so it's your choice what you want to measure. Yes? People online, give me a thumbs up if you have if you know what you're doing. Okay, cool. Good luck. Yeah, chat's okay.
Wait, come back.